Now we're gonna start this example. Okay, we need to integrate from 2 to -3 xt, and this is the value of xt. Okay, before we do any integration of a unit step, there are things that you need to know, or we need to do. Everything that we'll be doing, this is the range that we need to be t has to be equal to 0, or t has to be bigger than 0, or t must be positive. Okay, I'm going just to talk more about this. Let's say this is the graph. Okay, we have something like this for unit step. All right, we only need the positive side. Positive is wanted, so you want positive infinity. We need to have only positive value starting from 0 to plus infinity. Okay, and everything this side of this side, negative side, we need to reject it. Okay, we don't need any negative value on our graph. We're gonna need to reject it. Okay, so now what's he gonna do here? So we're gonna start now, and remember, keep in mind these formulas that I just gave you. So okay, so in this way we can start. Let me just move it up a little bit. Okay, so now we have this enough space to start. Now we're gonna check this t intervals if it's correct. So we're gonna start from -3 to 2, and then we're gonna check the unit step range. Okay, so what will happen here, before we start, I'm going just to break it down there, so to make it more visible. Okay, so now we're gonna break it down into 4 cases. So this integral, we're gonna put it in case as case 1, this one as case 2, this one as case 3, and this one as case 4. So now we have something that we can work with. So let's start with case 1. This is case 1. Okay, where's the integral? Write down this integral here. ut plus 5 dt. Okay, so now we have something like this, then we're gonna work out. And remember this formula that we used earlier. Okay, now what is t? T equal to 2 and t equal to -3, and this is the form that we have. So it's gonna be u plus 5 equal u plus 5 equal to u. Okay, so I'm gonna put 2 here, 3, -3 here. So it's gonna give us 7, then it's gonna give us 2. So if you check here, what you see inside, it's u of t. So which means t is positive and t here is positive. So this one verified. So this one verified. Let's go next example, next case. Okay, now case 2. And the equation for case 2, 3 negative 3 3 integral 2 negative 3 u t plus 3 dt. So now we have something like this. Now we need to check, and the formula is t, and the unit step. So now let's suppose t equal to 2 and t equal to negative 3. Now we're gonna have t plus 3 ut plus 3. So what is the value of t2? We get negative 3. So what will be the answer here? It's gonna be 5. Just keep the color. 5. Then here we're gonna have 0. Okay. We can see here this one is approved, and this one is approved. We start from 0 all the way up. Okay, next case. Okay, now case 3. What we're gonna do with case 3 now? We need to check for the interval inside here. Okay, so now let's pose our condition. If t equal to 2 and t equal to negative 3. Okay, now we have u of t negative 1, u of t negative 1, u of t. So what is the value of 2? T is 2 and negative 3. 2 negative 1 is going to give us 1. Negative 3 negative 1 is going to give us negative 4. Now in this case, this one verify and this one does not verify it. So what is going to happen here? We need to convert this in a such way it became positive. Not like positive, it's to be equal to 0. Since our integral, we're gonna start from negative, from 0 to plus infinity. This is how the graph is supposed to be. So we can have something like this. Then we start at 0, then we go all the way up, and the positive value are required. So anything that is negative has to be rejected. Like in this case, we need to reject it. So now we're gonna pose a condition where t, the unit step here, has to be equal to 0. So negative 1, if I put 1 here, what is gonna make this equation to be equal to 0? If I pose negative 1, 1 minus negative 1, so which means t equal to 1. So this one verified. So and t is equal to 1. So now this integral is going to change. So it's gonna be 2. 2 negative 2 unit t minus 1 dt. So this one verify -1 where we have 2, t equal to 2, but where we have t equal to 3, it doesn't verify it. So this one here, so this one verified. So since it doesn't verify, we're gonna put this value here. It's gonna be 1, t will be equal to 1. This is for case 3. Now next case C. Okay, so now we have another example. So it's gonna be t -5 t -3. Okay, if t equal to 2, t equal to -3. -2, -5 is gonna give us -3. -3, -5 is gonna give us -8. Okay. Now, if you check here, you're gonna see that this one is rejected and this one is rejected. In the case where both integral intervals are rejected, that means we're gonna have to reject the whole equation. Reject the whole integral, so which means you're gonna reject everything here, because both intervals are not valid unless if this interval was valid, but in this case it's not valid. You see? So now when everything is not valid, we reject everything. So this integral, you're gonna assume it equal to 0. Take note. Okay, so now this is what we have on this integral. Okay, so this is what we got. Case 3 and case 4 equal to 0, and this one valid, invalid. So this two invalid, and this is what we got from this integral. So now I have to write the integral, the final integral. So it's gonna be case 1, case 2, and case 3 only. Okay, so now this is what you're gonna have for our final equation. For case 1, -3 tt plus 3 -3 dt, -2 for case 3, then -0, it's gonna be +0 here. Okay, this is what we're gonna have, and remember this is for case 1, case 2, and then case 3, and this case. Yeah, there's this one's not 3, it should be -1, and this one should be -1, like we got in this case 3. Okay, now if you run this equation to the calculator, you're gonna get the answer. Yes, this one is it's 1, sorry. Okay, and this one is 1, +1. Now if you run this equation, Remember this one's positive, like we find here. We found there. Okay. If you run this, you're gonna get the answer as and the answer is 23 for this question here, as you can see. Okay, final answer as 23. There we go. This is what we have for this question here.